we'll talk about binomial distributions. What are they? Well, a binomial distribution summarizes probability for a random variable x. What is x? X is the number of successes from n trials when the probability of success is p. Now we assume that n and p are known, and we also assume that the childs are independent. If that is the case, then the probability of x equals some little x is given by n factorial over x factorial times n minus x factorial multiplied by p raised x q raised n minus x, where q is the probability of failure, which is 1 minus p. Now what we have to note is success is any event of interest, and n factorial over x factorial times n minus x factorial is nothing but n choose x combinations, the number of ways in which you can obtain x number of successes from n trials. So let's look at a problem. Here's a simple example. Here's a simple example. Let's say the probability of winning a game is 0.1 to 1. Suppose you play the game in 15 trials, and we are assuming that the trials are independent. What is the probability that you win the game in exactly A, 4 trials, B, 8 trials? Now this is a binomial problem because n is 15 independent trials, and at each trial you either win the game or lose the game, so the success event is winning the game. So do we know the probability of success? Well, the probability of success is 0.1 to 1. So I know n, I know p, so I can find the probability that we are expected, which is over here. So exactly 4 trials and exactly 8 trials. So how do we go about doing this? Well, probability x equals 4 would mean you find the probability that you win in 4 out of 15 trials if the probability of success is 0.1 to 1. Well, I know that this can be modeled using a binomial distribution under the given assumptions. So what we have is probability of x equals 4. Well, that 4 is nothing but little x, and we know n, we know p. Well, all I have to do is plug it in the formula that I wrote previously, which would give me 4 factorial, which is n factorial times, excuse me, it's not 4 factorial, it's rather have to erase this. It's n factorial over x factorial times n minus x factorial. Therefore, we would have n being 15. So I would get 15 factorial divided by x factorial, which is 4 factorial, times 15 minus 4 factorial times p raised x, x being 4, and q raised n minus x. Q is 1 minus p, so it is 1 minus 0.121 raised n minus x, which is 15 minus 4. That would give me 15 factorial over 4 factorial times 11 factorial, 0.121 raised 4 times 0.879 raised 11. If you do a little bit of simplification, you can see that I could write 15 factorial as 11 factorial times 12 times 13 times 14 times 15 divided by 4 factorial is 1 times 2 times 3 times 4 times 11 factorial multiplied by 0.121 raised 4 times 0.879 raised 11. Now I could cancel that term and that term. I could cancel 4 times 3, which is 12, and I could also cancel 2 and 14 7 times. So it's 105. 7 times 14 is 105 times 13. We could find that. So you have 15 times 7 times 13, which should give me 1365. So the probability can now be written as probability of x equals 4 equal to 1365 times 0.121 raised 4 times 0.879 raised 11. And that answer is the answer times 0.121 raised 4. It's actually 121 times 0.879 raised 11. And my answer is 0.07082. So there is about a 7.082% chance that one would win in exactly 4 out of 15 trials when P is 0.121. In a similar manner, if I want to find probability of x equals 8, then all I have to do is change my formula. Everywhere I have 4, I replace it by 8. So I have 15 factorial over 8 factorial times 15 minus 8 factorial multiplied by 0.121 raised 8 and 0.879 raised 15 minus 8. So there has to be an easier way to find that. That is nothing but n choose x, where n is 15 and x is 8 times 0.121 raised 8 times 0.879 raised 7. We know using a calculator we could find n choose x, so I'm going to press 15 math over to PRB option 3 is combinations followed by 8. That gives me 6435. Therefore, the probability now would become 6435 times 0.121 raised 8 and 0.879 raised 7. So let me multiply this. I get 0.121 raised 8 times 0.879 raised 7. Enter. That gives me an answer of it's a very small number. I'll write it in the next page. So probability of x equals 8. In other words, you win exactly 8 successes. In other words, wins out of 15 trials where P is 0.121. It's the probability of exactly 8 successes out of 15 trials where P is 0.121. Now that answer is 0.000118988, which is nothing but 1.1988 times 10 raised negative 4. Note that e negative 4 is nothing but 10 raised negative 4. It's called the scientific notation. That's from algebra. So what we did is we found probability of x is equal to 4. We also found probability of x is equal to 8. I believe that answer was 7082, and that was 1.1988 times 10 raised negative 4. Both these probabilities are known as exact probabilities because you find it for one single value. X is equal to 4 or x is equal to 8. So instead of doing all these calculations, if you have a TI-84 or 83 calculator, this probability can actually be found much faster. So how do we do it using a calculator? How do we get this answer and that answer without going through so much work? Well, first thing to note is we're looking for an exact probability. Exact probabilities can be found using a PDF function on the calculator. So what does PDF stand for? PDF stands for probability density function. So I know that I have to use a binomial distribution in this case, and I know that I have to use a PDF. So I know that this is binomial. You couple that with the fact that I'll have to use PDF because I am looking for an exact probability. So binomial plus use PDF, that should give away that the TI function is binom PDF. So binom PDF has a simple syntax. It's n followed by p followed by x. It's n, p, and x. So n is the number of trials and p is the probability of success. And x is what we are looking for in the problem. So probability of x equals 4 in our problem could be easily found by doing binom PDF. N is 15, P is 0.121 followed by X, which is 4. And probability of X equals 8 can easily be found as binom PDF 15.121, 8. Let me show you how we could find these two values quickly using a TI calculator. If you want to go and use Binomial PDF, we press the start button, we press second vars, and we scroll down to Binomial PDF, select that, press 15, 0.121, comma 4, close paren, press enter, and my answer is 0.70819, which I approximated as 0.7082. Excuse me, it's 0.70819. If you recall, that's exactly the same answer that we had previously. In a similar manner, if you want to find the exact probability that x is equal to 8, all I have to do is press second vars, scroll to the option for Binomial PDF, not CDF, press PDF, n is 15, followed by p, which is 0.121, 8, and the answer is 1.1988 times 10 raised negative 4. So these two approaches are exactly similar to what the formula would do, but the calculator is doing or evaluating the formula for you, and you can actually find the answer in an easier way. So you may either use this approach using the calculator, provided you identify n, p, and x, and that you have to use a Binomial PDF, or you can use the formula-based approach, which we showed earlier. Using this approach, you have to evaluate ncx first, then multiply it by p raised x and q raised n minus x, and repeat the process, and you get the same answer. But the choice is actually yours. You may either choose this approach, which is slightly extensive compared to this approach, which is very straightforward. But the pitfall here is that you have to know what function to use. Right now we have to use a Binomial PDF, but there are situations where we'll be using a CDF instead, that we'll talk about in the next video. So this is how you use Binomial PDF.